This chicken is very but more very small. Show me this. Put it down. Put down. This. Last day I tell her it's going to boil. Why don't you take this? Huh? Take this.
Zulfi sir, good afternoon.
Good afternoon, sir.
Sir, Kiran sir is only taking class today, sir?
Yes, sir.
Okay, sir.
He'll be starting in 1 or 2 minutes.
Okay, sir.
He's here with us. Kiran sir, good afternoon.
Good afternoon.
We can start now, sir.
Okay.
Good afternoon, Kiran sir.
Good afternoon. Okay. Any doubt in the previous class? Any doubts so far? Have you come across anything?
No, sir, things are fine till now. Thank you.
Okay.
So far, okay, sir.
Okay. Okay, today I'll be starting testing of hypothesis. Okay, that is very much important role in designing any of the tests. Okay, how you design the hypothesis, that is the most concern for any researcher. Okay, so we'll be discussing about that today, and we'll be going through the steps. What are the steps are involved here, and we will see how we can do it in SPSS. Okay, let me start with the things. What I can do is here, I'll present my screen now. Are you able to see this?
Yes, sir.
Okay. Good. We came here so today to discuss about the inferences. Okay, how we actually design inferences for a real life problems. Okay, and here comes the picture. Hypothesis testing are most important tool in application of statistics in real life problems. Okay, so why I am telling you, most of them, okay, to start with something means assuming, and we are fulfilling the objectives based on the hypothesis only. Okay, without which hypothesis it's not possible to design any of the statistical tools. Okay, so when you are coming to the decision making, you have to focus much on this hypothesis testing. Okay, this is a very much important tool, and there are set of tools in hypothesis. Okay, there we come across different categories. Okay, that are divided in different types. I'll be explaining few of them in our today's class. Okay, and see that they have given the definition. Decisions are required to be made concerning population. Means if we want to study any particular population, okay, you need to take the decision. Okay, means you want to the check the differences between the different populations and different treatment groups. If you consider any medical example also, okay, you can go for analyzing the test. Means how the treatment groups are involved, and how we can check and how we can compare the one group to another group. That based on the decisions. Okay, what is our objective and how we are going to take decision. That is the most important thing in testing of hypothesis. Okay, and see that statistical tests are used in arriving at this decision. Okay, see, decision making is as a manager, or as a statistician, as a normal human being, we need to take a particular decision. Okay, and there are the different steps are involved. Okay, that we will see now. Okay, and see here, this is 5 ingredients to statistical test. Okay, and these 5 are very much important in the in representing, okay, in designing of hypothesis. Okay, and if you come here for these 5 tests, okay, null hypothesis, alternative hypothesis, level of significance, test statistics, and interpretation. Okay, anyone know the definition of null hypothesis? Anyone? Anyone?
So can you please explain?
Sir, it is
Ah.
where there is no significant difference between the specified population
Yes, yes.
and for the sample what we observe the difference, sir.
Right. That means null means you can tell that it is a 0, means there is nothing. Okay, so when you are framing hypothesis, what we are assuming here is there is no difference, there is no much things. Okay, there is no influence. Okay, there is no relation. Okay, between the average relationships. Okay, we are not dealing here a specific individual, we are dealing with a groups here. Okay, that is the main important in testing of hypothesis. We are not dealing here any univariate cases. Okay, that also I'm going to discuss now. Okay, null means there is nothing. Okay, so you need to assume that the process. Okay, so if you want to compare the heights of Indian and China people, okay, what we actually assume that in the beginning, okay, there is no difference between average heights of Indian and Chinese people. Okay, just assuming, we are assuming. Okay, by doing all other steps, we will be concluded, but we need to assume something first. Okay, and alternative hypothesis is opposite to this null hypothesis. Means when we are failing to accept this null hypothesis, we are going to accept this particular alternative hypothesis. Okay, so this is opposite to null hypothesis. Okay, and level of significance here, and we are actually dealing with the samples. Okay, that how the level of significance will come, and how you can go for concluding it. Okay, that I'll be giving you an idea how can we go for this significance. Okay, the significance level always Okay, we are dealing with 95% confidence intervals. Okay, level of significance means 0.05% or 0.01% in the statistical sense. Okay, so it is, we are assuming that, okay, whatever the information or variation is explaining, and we are going to give 90% of the of the information, and we are taking decision correctly with the 95%. Okay, why means we are accepting 5% error in that. Okay, as usual things. And if you want to make difference levels, okay, that also it is possible. Okay, maybe I'll be telling maybe the 99% also there, that is 0.01%. Okay, so what actually we do here, okay, we can frame the level of significance based on our requirements. Means, for suppose if someone electrical bulbs, okay, manufacturer of electrical bulbs, okay, if you are ordering 100 bulbs, okay, we are able to accept 5 failures only. Okay, so then we are calling it as a 95%. We are accepting 95 bulbs. If in 100 bulbs, in 100 bulbs, okay, there if 5 are 5 are failed, means there is no problem. We are going to accept your complete the item. Okay, items. Okay, so 95% will come. Okay, maybe if you want to fix that, and then you can also do that. Okay, and most probably in statistics, for uh, social science scientists, or any biology also, we will be fixing the levels, alpha levels, that is level of significance is alpha. Okay, alpha is 0.05 or 0.01. Okay, most significant comes for 0.01. And the test statistics, this is the very much important phase to select which tool, okay, which tool is appropriate for a particular data. Okay, that you need to remember always. For based on the data, means you need to observe the data very clearly, and see whatever the application, whatever the real life problem you are applying for a particular test. You need to understand the understand the problem first. Okay, if you understand the problem, then you are able to choose a appropriate statistical test. Okay, if you are not understanding, if you are going blindly, then there is nothing useful. Okay, many of them, they will not understand the problem first. Okay, they'll go by their blindly, they will go with the different tests. Okay, that will not suit for them. Okay, then they will face the problems in middle. Okay, so try to understand the domain what you are working. Okay, then you can choose this list of statistical tools. Okay, I have one book with me. Okay, 100 statistical tests. Okay, that also I'll share you. And one more thing, like marketing research, one book is there. Okay, so that will Naresh K Malhotra. Okay, that is a very good book. They have explained it very clearly. Okay, that I'll be showing you. Okay, how you are how you can choose a particular test for a situation. Okay, and after applying this, interpretation is uh, is another important phase. Okay, means final stage, means a decision maker has to take the decision, means interpret the results based on the what test is going to apply. So this is the other important phase and the final one in the statistical hypothesis. Okay, so those who are not understanding, you can ask me at any time. I'll be here to tell you one more time. Steps in hypothesis testing. What is the first step? Okay, what is the first step is? First is here, identify the null hypothesis. Means we are assuming that there is no significance difference between the average number of variables, means sample means and sample and populations. Okay, that we are actually going to do. Okay, and there were different tests are there, a small sample test and large sample test. Okay, small sample test is the observations less than 30. We are going to use that sample, a small sample test, and if the sample size is greater than 30, we are going to use large sample test. Okay, so in this particular sessions, okay, I'm going to cover small sample tests only. Okay, and that is enough for you to understand the hypothesis concepts. Okay, and see that choose alpha. Okay, alpha means I told you that this is the level of significance alpha. The value should be small. Okay, usually less than 10%. Okay, and see that it is important to consider. See, up to sometimes up to we can bear up to 10% also. Okay, important to consider the consequences of both type of errors. Okay, so here I'll be showing you a table. Okay, there you are going to understand how these type of errors are coming. Okay, so and see that select test statistics and determine its value from the sample data. And this is called the observed value of a test statistics. Means whenever selecting a particular test, okay, you need to calculate the value first. Okay, so the software, what it does is it makes you easy to compute these calculated values. Okay, so observed value of a test statistics, that actually that part is doing by the SPSS now. And before that you need to have a theoretical explanations how we can design a tool, and how much you can understand this particular statistics, and how you can apply for a real life problems. Okay, that is main important. Before going to do any kind of research, try to understand the data behavior first. Okay, so that only we have designed so many statistical tools, okay, from basics to advanced. Okay, for any reason, okay, for any of a purpose we have designed. There were much of statistical tools are available, okay, to deal with from basics to advanced. Okay, we are here to touch basic things only. Okay, we are giving what we required for your research. Okay, and those who are in a final year PG, okay, they can also enter into the research. Though that's only the motto of conducting this particular workshop. Okay, and see what we are doing here in the fourth step. Compare the observed value of the statistics to the critical value obtained for the chosen anyone. Okay, so make a decision. Okay, fifth step is very much important. Okay, we need to make a decision. Okay, as a manager. Okay, as a statistician, as a decision maker. Okay, so that there comes your skills. Okay, what you are learning of all the statistical tools, that will be useful for you in this step. Okay, so the making decision is a crucial step. Okay, regarding anything, maybe if the government introducing any policy, okay, they need to take a decision. Okay, decision making in our lives also, okay, that is the most important crucial part to to be taken, so that only we are planning our things. Okay, if the test statistics falls in the critical region, okay, so reject H0 in favor of H1. Okay, so when it is coming into the critical region, I'll tell you in the next table it is there. Okay, if the test statistic does not fall under the critical region, okay, conclude that there is enough evidence to reject. Okay, so that's only we are actually going to do means the falling region. What I told you that in a normal distribution, we have the regions. Okay, so 95% confidence intervals. Okay, so the edges means the tails, we have some errors means 95% means we are segregating 5% into two parts, and where this particular decision is falling, okay, there we are going to reject or accept this particular hypothesis. Okay, and you see here, this is, I think I will stop here for a theoretical explanation. Okay, so types of errors. Okay, we need to understand the type of decision. Okay, so when H naught is true and H naught is false, okay, and reject H naught, accept H naught. Okay, so you see here how we are going to do that. Okay, so one is when the H naught is true, okay, when we are rejecting that, okay, then we are facing this type 1 error, that is alpha. Okay, so and when H naught is false, we will be going to reject. This is a correct decision actually. Okay, when you are accepting the H naught, that is correct decision. Okay, H naught is true, then we are accepting, and H naught is false, also we are accepting. There comes the picture of type 1 and type 2 errors. Okay, so type 1 error, what actually it means that I'll be giving you a medical example. Okay, so type 1 error is if someone, like if a patient's having a particular disease, like suppose cancer you take, but we are concluded that we are rejecting this particular one. Okay, so what happens this one? Okay, so and if you see here for type 2 error, what happens, even though you don't have anything, okay, they're trying to pose that you have something. Okay, so which one is dangerous in these errors? Anyone? Here we have a particular disease, but we are rejecting, means we are telling there is nothing. But here we don't have any disease, but we are accepting, we are telling you have that. Okay,
Type 2 is dangerous.
okay, type 2 is dangerous. He don't have the things. Okay, you don't have a disease. Okay, but they are assuming that he has something. Okay, so what is dangerous here? Okay, type 1 is always dangerous. Why means
The alpha, sir.
alpha is always dangerous. Why means we have a disease. Okay, but they are telling that you don't have. Okay, what happens? Okay, it is very dangerous, means if you don't have, but they are confirming that you have. Okay, in the later stage you can be knowing that. Okay, then you will be out of danger. But in this type 1 error, you will be having already disease, but they are telling you don't have. Okay, then what happens? Okay, gradually your health will go decline. Okay, the health levels, okay, energy health levels. Okay, so what happens? Okay, you will see something mishappening in this particular error. Okay, so keep remember when you are taking decision. Okay, maybe you see this theory in the research methodology book also by C.R. Kothari. Okay, C.R. Kothari, those who are just maybe started a research. Okay, you definitely follow that book. There's research methodology by C.R. Kothari. Okay, you can buy that book also. It is maybe 300 to 350 only. Okay, those who are researchers and those who are interested in doing research, go for buying a book. Okay, that book is very much essential for anyone. Okay, okay, so I'm closing this. I'm opening another one. Okay, that is actually one. Okay, this is a marketing research. Okay, and orientation by Naresh K. Malhotra. Okay, this book has given an information about all the type of questionnaire design, everything they have given, whatever we discussed so far. Okay, general procedure for hypothesis testing. Okay, that we are actually that the step by step they have explained here very clearly. Okay, so you can see this book. I'll be sending you this book also in the last classes. So you can see that. Okay, so how the steps. Okay, these are the general procedure of hypothesis testing. Okay, that they are explained in a schematic diagram. Okay, what is the first step? Okay, formulating null and alternative hypothesis. Okay, step 2 is selecting an appropriate test. Okay, choose a level of significance. Okay, so you need to select whether you are going with a 95% confidence intervals or 99%. That is up to you, and you can accept up to 90% also in the extreme cases. Okay, so this is the steps what actually we need to follow when of any of the statistical hypothesis procedure. Okay, so you need to take a decision. Okay, we'll be discussing about a small sample test today, and I'm touching t-test and the Anova, one-way Anova. Okay, that we cover today, and we'll close this session for today. Okay, in the next week, what I do is I'll cover little more. Okay, of non-parametric test of for 2 sessions in the last week. Okay, this is another one you need to remember. I'll share this with you. Okay, so that you'll be getting an idea. And one more book I'm going that I'll be showing you here. So where it is.
Will you share the book today by the end of the session or later?
Yeah, end of the session also, there is no problem. I'll be sharing with you. Okay, so I'll do one thing. Okay, I'll copy this book link. Okay, if you just click on get, you'll be going to get this book. Okay, just I'll be sharing that. Okay, I have that. Are you able to see my screen, or which screen it is visible to you? The book?
A book, the Naresh K. Malhotra book.
Okay. So I'm sharing here the book. Okay, so you can just click on that and get the book. Okay, that is the only thing you can do it. Okay, are you able to see this another book? Are you able to see another book?
Yes, sir. Under statistical test, sir.
Yes, by Gopal K. Kansi. Okay,
Yes, sir.
it's a very brief book. Okay, it will not very deep, but for those who are starting their career, okay, in research career, this is a very good book for you to understand the concepts. Okay, so 100 statistical test by Gopal K. Kanchi. Okay, this book also available. Okay, maybe I'll be sharing you some of the sites. Okay, some of you know about Z library. Okay, Z library or library Genesis. Okay, that and all the the sites where the books are available. Okay, you can try to download the analysis books and all. Okay, and whatever your whatever useful for you, that is also available. Means the based on the domain. If someone is working on economics, finance, management, okay, so social sciences, okay, many things that you can download from that book, and Indian authors will not be available. Okay, so much. Okay, not
Sir, you said
not
Jet library.
Jet library. Okay, I'll be sharing you that link also, so that you'll be getting the things. Why means I'm giving you much information about how we actually you go for doing any research. Okay, I shared it with you. Said it is coming to you. Library Genesis in chat box. You are able to see the chat box.
Yes, sir.
Oh, good. Okay, Jet library is there. Okay, so you can choose that. Okay, books, articles will be there, and you can also log in with that for downloading more. Okay, if you are not logging with the Jet library, then it will be we are able to download only you are able to download only 5 books. If you log in, it is free login only. If you log in, you can download many books. What happened? This is coming. Yeah. Okay. So those who are interested, maybe research methodology book also available in the library Genesis or Jet library by C.R. Kothari. But maybe if not, try to buy a book. Okay, my sincere request is try to buy a book and learn the things. Okay, they have given very uh, what we can say, very easy way, okay, to enter into the research.
The share Kothari is also available online for purchase, sir.
Yeah,
Uh,
purchase
but
Amazon,
physical
Flipkart.
copy,
Okay.
sir.
Yeah, Amazon, Flipkart. No, it is available.
Yes, sir.
Okay,
Yes, sir.
nearly 300 to 350 will be there. Okay, try to buy that book. Okay, for those who are interested in doing manual also in Excel also, we can do that. Okay, that they have given that much things in that. Okay, I'm showing you here how these statistical tests will be useful for, and my concern is I'm going to teach you the t-test for uh, for for comparing the means. Okay, so that I will be touching here. Okay, there are different things they have given, but we don't have much time to discuss much things as a theory. Okay, and I'll see that where these contents. Okay, I told you this one. No? I told you this situation. Okay, conclusion. Okay, what you do, whatever the statistical test you do. Okay, this is important. Okay, this based on this only you need to take a decision in every pair. Okay, so they're given a complete information why we need to take the hypothesis. Okay, and those who are doing the normality things, means normal distribution, having the capability, okay, to assume all the parametric, most of the parametric tests. Okay, you see this here, this line. What is the line? Okay, most of the parametric tests considered in this book have made the assumption that populations involved have normal distribution. Okay, have normal distribution have that much potentiality. Okay, so it will all the distributions in our statistics will follow a normal distribution. Okay, those who are good at learning this distribution. Okay, for you all the tests will become easy. I'm telling you. Okay, so theory wise, you go for learning these distributions. I'm telling you. Okay, and see that the see how the hypothesis will be framed here. Okay, So this is the hypothesis, what actually we are going to do. This is example they have given. This is Z test. It is for the sample size is more than 30. Okay, that's only we actually use this one. Okay, I'm not touching this Z test in our curriculum, but you can utilize this. Okay, what actually we do, what hypothesis will do. Okay, what hypothesis will do is, okay, so here hypothesis what you are framing. Okay, so this one, when you are comparing sample with population. Okay, sample with population, we are equating the sample with the population, means mu is mu naught. Okay, and here alternative is that is not equal to. And another also we are going to tell here, okay, whether these population mean is greater than the specified point or difference. Okay, that also we can discuss with that. Okay, and you see that what I told you, that that normal distribution. Okay, normal distribution have the edges. Okay, tiles. Okay, how you can define the normal the confidence interval. Okay, level of significance, it is based on these particular one. Okay, see 1.96, it is nearly 90 97 point, nearly 96.7 will be covered. Okay, nearly. So what actually we are doing with the normal distribution of 1.96 with the different standard deviations. Okay, these two things, okay, 0.05 we segregated. That is, we actually call it as the both the tails. Okay, both the ends we have error, means if any point of the decision, it will fall under this line, this region. Okay, this region actually we call it as a critical region. Those samples, those decisions will fall under this region, then we are rejecting the hypothesis. Okay, so if you are learning normal distribution, okay, based on the normal distribution only, we try to conclude our things. Okay, how the critical region is defined. Okay, if you see here, what is this mu is greater than some point in the population. Okay, what it is, a right-tailed one, we actually call it as. Okay, one-sided. Okay, one-tailed you have seen yesterday. No, what is one-tailed or two-tailed? Okay, have you remember yesterday's class, one-tailed, two-tailed, when you are doing SPSs? Okay, someone asked a question also. Okay, this is comes for a two-tailed one, and when you are dealing with this one-sided, okay, either left or right, then we are calling it as a one-tailed test. Okay, based on the specific problem, we are choosing any one of the things, and most probably we will consider two-tailed tests. Okay, that is the only thing we are actually going to remember. Okay, so without delay, we'll be going to our statistical tools. Okay, and I think I have to go for test 8. Okay, this is actually we are discussing with the t-test. Okay, this is useful for comparing the means. Okay, comparing the means, those may be in any of the practical situations, we actually do the comparison. Okay, so here the different type of t-tests are there. Okay, so they divided the t-test into 3 types. One is t-test for a single mean. Okay, single mean. Okay, when you are discussing about any population, okay, so you are making a cutoff for the cutoff point for that, and you are comparing with a specific value. Okay, means you have a set of observations, and means that I'll be giving you an example. Okay, so the average height of an Indian, okay, is is 5.5. Okay, just assume that it is not a correct one. Just assume that approximately 5.5. Okay, I'm telling you that average height of an Indian, okay, is 5.5 inches. Okay, so what actually we are doing, if you take 10 observations, otherwise we take these participants, okay, we compare each sample, okay, each observation with the with the with the cutoff. Okay, so what we have taken. Okay, are you understanding, or still you have anything? Okay, I'm I'm able to reach you.
Yes, sir. Yes, sir.
Okay, thank you so much. Okay, so we are comparing each observation with the sample, with the cutoff point, okay, with the specified value. Okay, so we are doing a comparison of the means. Okay, that only we are actually doing. And see that the formula, okay, formula for that is, see, assumption, how you are assuming here, that is mu is mu naught, mu naught, this is null hypothesis. That is, we are assuming that all the heights of Indians are same, like what we are given cutoff point, that is 5.5 inches. Okay, so 5.5 feet, okay, not inches. Okay, so what happens then? You are rejecting that. Okay, you are rejecting that. That means that differ. Okay, differ with the heights. Okay, what is the test statistic we are going to use here is this is test statistics. What is X bar? Anyone know the X bar? Anyone know the X bar? Okay, it is a sample average. Means, if, for suppose if you take 10 observations,
Arithmetic.
yeah, 10 observations, that we are taking average for that, and we are making the difference with the cutoff point what we have taken. Okay, so that only we are comparing the means of a sample with a population. That's only here. And S by root n. Okay, S is sample standard deviation that we are actually doing here. S by root n. This is the formula for a t-test for single mean. Okay, so this is the one we actually going to do that. And this is the sample standard deviation. Okay, and see that we are actually always we use sigma square. Means this is the variances or is not known, and the estimate of s square of sigma square is based on this small sample. Okay, n is less than 20. They have given 20, but we can take up to 30 also. N is less than 30, and a normal distribution. So we can take, we actually assume that variances are equal. Okay, for both the cases. I'll be coming to you for the second type of t-test when I'm discussing with that I'll be doing for you. Okay, and you see that what is the degrees of freedom here. Okay, degrees of freedom is very much important here to consider. Okay, so that you need to take this particular value. Okay, there are set of tables designed by the statisticians. Okay, so t-test tables for a particular degrees of freedom that they have given to you. Okay, so this is nothing but your critical value or tabulated value. Actually, we actually call that it as a tabulated value. And why this n minus 1 came? Okay, n minus 1 means you know the all observations. Okay, so why it is coming minus 1 is, okay, if you know 10 observations, okay, so then why we are giving, why we are taking 9 only, means n minus 1 9 only, means if you know 9 observations, 10th observation will be automatically known to you. Okay, 10th observation will automatically known to you. Okay, so for that reason only, okay, so we have taken here minus 1. Okay, so the degrees of freedom for different cases it is different. Okay, so the initial one, we are coming up with this n minus. Okay, I'll be going to a practical problem here. What we are going to do in SPSS, that we check now. Okay, are you able to see this? T-test for single mean.
Yes, sir.
Okay, so what I'm doing here, the 10 students are selected at random from a school, and their heights are found to be this. They have given in inches. Okay, so in the light of these data, discuss suggestions that mean height of the students of the school is 54 inches. Means they have given a cutoff. Okay, see, average height of a student in the school is 54 inches. Okay, we may use 5% level of significance. Okay, so we are going to use here 5% level of significance. If you go for tables of t-test, okay, for different 5% level of significance, okay, with a different degrees of way down, we have a value that is tabulated value. In SPSS, the beauty of SPSS is that will as already comparing with the calculated value with the tabulated value, and will you give you the results. Okay, so without showing that, it will show you only the calculated value of a particular test statistics, and it will show that whether it is a significant or not. Okay, that only we actually do here. Okay, so what is our hypothesis now? What is our hypothesis now? See here, mu is, what is mu? Okay, mu is our cutoff point. Okay, that actually 54 inches means the data are consistent with the assumption that the mean height of the students of the school is 54 inches. Okay, so alternative is this opposite to this one. Okay, are you getting it?
Yes, sir.
Okay, thank
Yes, sir.
you. Okay, now I'll be going to this the particular one. We'll do it in the SPSS. Are you able to see my screen, or what is showing you?
We are seeing the 10 students are selected at random, sir. That
Okay, one moment. I'm stopping and opening again. Okay. Now I have entered the data in the data view. Okay, so I entered 10 students of a school. So what happens when you go for variable view? What is here? Okay, these are numeric and height of the student, and value is nothing. By means it is a quantitative thing, so we cannot give any labels here, values here. Okay, and measure is here. This is the quantitative type. So we are actually doing with this one. Okay, so scale. Okay, now I'm going here with a analyze. Okay, there comes the picture of compare means. Okay, are you getting it? Compare means. Okay, so now here we need to select the one sample t-test. Okay, are you getting it? One sample t-test. Okay, if I select here, what happens? This came here, and we need to move this one to this box as test variables and options. Okay, what is option here? Okay, automatically by default it is 95%. Okay, so missing values or exclude cases by analysis. Okay, so that will be coming with you. It is not added in the things here. One moment. Okay, so what we are doing here, just continue. Okay, and this one you need to remember. Okay, this one you need to remember. What is this? What is this?
54.
Yes, there you have to give 54. Okay, that is the cutoff point they are given. They have given by the school. Okay, 54 inches. Okay, so I have made here as a 54. Okay, are you understanding this? Or can I do one more time? Anyone? Or I have still doubt in this?
So can you just please repeat the menu that you went?
Okay, so this is the heights of the student in a particular school. Okay, so they have given average height. Okay, of the school is 54 inches. Okay, now we are going to compare the sample mean. Okay, so we are going to compute this mean and we are going to compare with the cutoff point what they have given to us. That is population mean, we actually call it as. Okay, entire school they are taking, so that we are calling that as a population mean. Okay, this is the sample mean. Okay, that is x bar minus mu naught that they have fixed with a population, means entire students of a particular school. Okay, will come with a population, means a particular school have this many students. Okay, their average height is 54 inches. Okay, now what I'm doing here, in the variable view, you need to select measure. Okay, scale. Okay, that we are doing here, and analyze. I'm going to analyze. There is a the thing compare means. Okay, the item compare means. I'm going here one sample t-test. Okay, what we are doing, we are comparing sample mean with a population mean. Okay, that is the only thing what we are doing in a single mean, t-test for single mean. Okay, so I'm moving this one to the test variables options. It is by default 95%. Okay, missing values or exclude cases by analysis, that the analysis by analysis that we do. Okay, if anything missed, then it will be excluded. Okay, so bootstrap is not required for you. And what is the test value? In the place of test value, what they have given to us, a target value or a target mean, that is 54. Okay, so we are going for clicking. Okay, and are you able to see the output window? No.
No, sir.
I'm opening it. Okay, now.
Okay, sir. Now.
Okay, so what actually it has given is mean is 55, standard deviation is 3.09. Okay, so heights of student. Okay, what is the calculated value? Is here 1.023 and n minus 1. I told you, no, there are 10 observations. 10 minus 1. Okay, 9. So they have given significant two tile. What is here? 0.033. So what we can conclude with this, the test value. Okay, so what they have given here, if you come across this mean, okay, 55, what is our cutoff point? What is our cutoff point?
So 54.
So by seeing this itself, you will be getting that this is more than that. Okay. Most probably there will be no significance. Means what actually we have given? We have taken null hypothesis. What we have taken null hypothesis? Anyone?
Sir, mu equals to 54.
So the average height of a school is 54 inches. Okay, we don't have any evidence to reject the null hypothesis here. Okay, by means the mean is already 55. Okay, the calculated value is 1.03023 and the degrees of freedom is this, and by seeing this it always the calculated, okay, the compared this calculated value with the tabulated value, and it found there is no difference. Okay, that means there is no evidence to reject the null hypothesis. So what we are doing, we are accepting the null hypothesis. Okay, are you getting it, or still you need some more explanation for this? Are you clear about it?
Sir, we accepted our null hypothesis.
Yes. If it is less than 0.05, okay, so we are rejecting the null hypothesis. Okay.
Sir, it's the 0.33. It's showing two-tailed, right?
Uh-huh.
So this is what you were showing in the diagram.
Yes. That is two tail means it will consider means both tails it will consider. Okay, so most of the tools, okay, they'll be doing with the two-tailed only. Okay, only specific cases, those who require that only they will do for. That will be they will be giving you for information that. Okay, two-tail means what you can write is here 55 plus or minus 3.09. That we can write. Okay, that means that will go to up to down 52 and 58. If you see the data distribution here, okay, I'll show you another. Where is the book? Okay, so where it is started, okay, say 58, 59 also there. Okay, 50, it has started with the 50 and 59. Okay, so we are comparing here the average relation, averages only. Okay, so we are not comparing with the individual with this code. Okay, combined average of these observations, and we are comparing with the population mean. Okay, procedure also we have given here, and see that this is the table what we actually showed there. And what is the interpretation now? Okay, T calculated value at 9 degrees of freedom is 1.023. And this P value, we are telling level of significance value at 95% confidence intervals, or this is 0.03. Since P value is greater than the 0.5% level of significance, there is no evidence to reject the null hypothesis. Since we are accepting the null hypothesis, means you need to understand these steps. Okay, are you getting it? If it is less than 0.05, then we have an evidence to reject the null hypothesis. One moment.
So can we calculate one-tailed data with this?
He is on the phone, I think.
You are asking something?
So can we calculate one-tailed data with this processor?
No. Actually, in single me, we are going for writing only 95% confidence intervals. Okay, we can do it one-tailed also, but in SPSS it is not showing. Okay, it will take automatically directly two-tailed. Okay, in other maybe in R programming we can specify. Okay, we can specify, but here it is not possible to specify. It automatically takes you two-tailed. Okay.
Sir,
Okay, sir. Thank you.
sir,
Hmm.
this regarding the two-tailed, I just did in my SPSS. There was significant was showing both one-sided P and the two-sided P.
Okay, where it is in SPSS you are telling?
Yes, sir. Just if I can share the screenshot.
One moment. Actually, one minute, I'll come to you. One call has come. I just sorry for the interruption. Tell me, so you are telling something. Single tail and two tail.
Sir, I've sent you a screenshot.
Okay, where in chat box?
Yes, sir. Personally.
Uh, okay, one minute. Yeah, you are right. Okay, so this is actually the advanced versions. Okay, recently came for maybe 24. Okay, SPSS 24. Okay, that is giving you this type of one title also.
Using the latest one from the website.
latest versions of SPSS. You can find out one-tailed also. Okay, this is the older version I'm using, that is 22. Okay, it cannot come for that. Okay.
Okay, sir. Thank you.
Okay. Okay. I mean, I already work with that, but I have seen many of the projects also who done under my guidance. Okay, some students they sent me. Okay, with this one tail, two tail also. Okay, so that it is the advanced versions of SPSS that will give you all the results. Okay, means every time they are going to enhance, they are enhancing the things. Okay, so where we are now, we are actually in the interpretation of these.
So you were showing the PDF.
Okay.
Sir,
Ah.
the SPSS that you have shared with us is also 22. The one we downloaded on the day one, sir.
I'm not getting you. Please loudly.
Sir, the SPSS we downloaded.
It is 22. It is
that is on the
22.
version 20. Is that the latest one or there's more?
No, it is 20. It is actually latest version is I think 24.
Oh, okay, okay, sir.
Okay, this is 22. Why means see the pirated versions they will not give for advanced things. Okay,
Okay.
so lower levels only they will give. That's only the thing. Okay, so this is actually permanent for you. Okay.
Yes, sir.
Okay, it is a permanent thing for you. Okay, it will be always available for you. Okay, with this cracked version.
Yes, sir.
Okay, and we don't need for advanced things. Those who are started research basic things, that is enough for you.
Yes, sir.
Okay. So what is our calculated value? Is 1 point. 1.023, and so there is no evidence to reject the null hypothesis since p value is greater than 0.5. So actually, someone is disturbing us. Okay. So what we where we conclude here?
Sir, here the sample, sorry, the whole population we are taking 100%, right, sir? In this calculation. So, is there any set formula to take the sample, sir?
Samples I actually no, actually that is a different thing. Okay, so we can take at least 2 to 3 sessions, means at least for 2 days if you are going for the calculation of sample size and different sampling techniques are that is completely different.
Okay.
Okay, defining sample size and questionnaires, everything. Okay. Okay, that is different item. Okay, so those who want these tools I am explaining you, and those who maybe advanced things also, we need to place a separate thing for you. Okay, so calculating sample size with the different sampling plans are there, sample types are there, simple random sampling, stratified, systematic sampling, cluster sampling. Okay, by that when we are taking that. Okay, so you need to define your population, and in the population you need to select based on the sampling procedures. Okay, then we can decide the sample size for that.
Okay.
Okay, so what we are concluding here, we conclude that The data are consistent with the assumption of mean height of 54 inches in the students of the school. Means they are maintaining the same thing. Okay, for the particular school. Okay, so I'm moving to the next one is t-test for equality of means. Okay, now what we are doing here, we are comparing two samples here. Okay, not with the population. Before that, what we did, we did with the comparison with the population mean. But here we are going to do with the sample means of two groups. Okay, that we are actually going to do here. And before going to that, I'll be showing you the formula for this. Okay, so this is the test number 8. Okay, so where actually we are going to see that. Okay, we can also write this one. Okay, this type also, or we can write with this one. Okay, mu1 is mu2. Okay, for simplicity, you can use this one as the things. Okay, the formula is here. I'll show you the formula only. Okay, I'll not explain you much of the things of that. It's time consuming for us. But I'm telling you, those who are good at theory, okay, they only learn the things. Otherwise, it is like a different things for them. Okay, what actually we are doing for taking difference of two means, x1 bar minus x2 bar minus, we are means both, for both the things there will be a population means. We are comparing these things to this sample means to population means. This formula is refers to the t-test for independent of means. Okay, two means. Okay, and see here what actually the degrees of freedom here, that is n1 plus n2 minus 2. If you have taken 20 observations, what it will come? Okay, overall 20 observations. Okay, 10 plus 10 minus 2. Okay, so how many coming here? Degrees of freedom is 18. Okay, so I'm giving you, and you can go through the formulas in that. Okay, I'm the time limited things I'm covering only these things. Okay, and if you see here, by testing of hypothesis is very much important for any researcher. So that's why I'm going very slow. Okay, I can teach you in a faster manner. Okay, but you need to learn this, how to do it. Okay, so here the problem is we have taken in a test given to two groups of students. The marks obtained were as follows. Okay, so first group and second group, we have actually obtained the marks. Examine the significance of difference between mean marks obtained by the students of the above two groups. Okay, test at 5% level of significance. Okay, so what we are doing here, what we are taking hypothesis is mu1 is mu2. That is, the meaning is there is no significance difference between the marks of first group and the marks, and see that this is important. Okay, this is important. Okay, if you are not writing this, you are not applying t-test. Okay, so when you want to compare means, okay, up to two groups only. Okay, up to two groups only, we are able to compare with the t-test. We are able to compare means with the t-test. Okay, more than two groups, what we are going? Anyone guess that? More than two groups comparison, mean comparisons. What we are doing? Anyone?
Sir, ANOVA test.
Yes, as we are going to ANOVA for doing more than two groups, more comparing more than two groups. that comparison of means of more than two groups. Okay, and that also we will see now. If time permits, I'll be going very fast. I don't know. Okay, but I need to cover the things. Okay, if I able to cover today Anova, I'll cover. Otherwise, we'll talk in the next week. Okay, Anova chi-square is there. Both the things I'll be covering for test of goodness of fit for and the test of attributes. Okay, that we will cover. Why means in the social science of management people, so they always do with the attributes. Okay, so I'm covering with that, and some of the non-parametric test I will cover in the next week. Okay, so this is the hypothesis we framed here. This one is two-tailed one. Okay, we have taken opposite to this. Okay, so I'm going here to open equality of means. Okay, are you able to see my screen? Only PDF is available, no? I'm stopping the screen. Okay, I have entered the data. Okay, and I see that here this is very much important when variable u. Are you looking this? Are you able to see the screen? T-test
Yes, sir.
for equality of means.
Yes, sir.
Okay, so variable 1 and variable 2. Okay, marks of the student and grouping. Okay, this grouping is very much important to you. Okay, so with that grouping only we are able to compare the means of two groups. Okay, so here this is the scale parameter, and if you see here how to enter the data into the SPSS window. Okay, so what I have given, I have taken all the observations in a first column. Okay, are you getting this? Why I have written this? Okay, you need to write this one. Otherwise, t-test will not work here. Okay, for Anova also the extension. Okay, more than two groups, we can add one more than two groups here and compare. Okay, so whatever the variables observations they have given for a group that they have given, and we are segregating with the group names. Okay, 1 and 2 we have written here. Okay, are you able to understand this? How we can write this one?
Yes, sir.
Okay, we need to entering the data is very much important when you do for t-test for two means and Anova. Okay, so we are
Sir,
grouping.
Sir, can you just once again go to the variable view and tell that this is automatically done by the SPSS, right?
No. It will not. It's not automatically done by this. Okay, here it is not the scale. Okay, what is here? What is here in grouping?
So, uh,
There are two different groups. Okay, there are two different groups. We are selecting as nominal. Okay, you need to understand this. It is not the scale value, quantified value. Okay, they are given different groups here. Okay, are you getting it?
yes, sir.
Okay, so this is the thing you need to remember when you do the test statistic or test of equality for the t-test. Marks we are entering in the data view. What we are doing, we are entering all the observations in the first column, and grouping variable we are giving it to the next column. Okay, so and marks is quantified already. They have given with the quantified things, but these things are grouping the things or different. Okay, so we are selecting nominal. Okay, so can I go to the analyze now, or still you have any doubt on entering this data into the SPSS editor?
Like, can you just please once again tell why we did the grouping and what's the logic behind it?
Yeah, actually we need to segregate the groups. Okay, they have given to compare two groups. Okay, two samples we are comparing. That samples how it is taking. Okay, so we need to compute the mean for each group. Okay, mean marks of a first group and mean marks as a second group. How you compare? Okay, you are doing now. Before that, t-test for single mean, what it is showing. Okay, we are actually doing for one group only. With the we have a cut point there, so we are comparing with the cut point for each observation, but not here. Okay, we are comparing the means of, even though the groups observations are not equal. Okay, you see that whether group observations are equal. Okay, how many variables here? 1 2 3 4 5 6 7 8 9.
9.
Okay, 9 in the first group.
Yes,
Okay, it won't bother about the equal number of observations in any group. Okay, it is bothering about the means of each group. That's only the thing here. Okay, how many variables here in the second group?
7.
7. Okay, so it will not consider anything. Okay, regarding these observations. Okay, if it is equal, there is no problem. But if it is not equal, also there is no problem. Okay, so our main motto is to compare means of two groups here. Okay, are you able to get this one?
Yes, sir.
Okay, good. Now, can I go to the analyze?
Yes, sir.
Okay, analyze, compare means, independent sample t-test. Okay, so here you need to remember the two things. One is test variables, the scale variable go to here. Okay, and grouping, here grouping variable is there, and you need to insert here grouping, and two question marks came here. What is the two question marks? Means we are comparing two groups. Okay, so when the question mark came, what are the groups here we have written? Okay, what are the groups we have written here?
1 and 2.
1 and 2. Okay, define groups. Okay, use specified values. Okay, this is first group and this is second group. Okay, continue. Okay, this you need to remember to give this one. Otherwise, see, now question marks are not there. What it came? The groups 1 and 2 came here. Okay, are you able to see this one?
Yes, sir.
Yes, sir.
Okay, good, very good, very good. You are following things. Confidence interval is automatically it is 95%. Okay, we can change here 99% also, there is no problem. Okay, so it automatically will be there. Okay, missing values it can take. Okay, so now
Sir, what was that cutoff point in that defined groups?
हाँ और
Okay, sorry for the thing. Suddenly my net has gone. Okay, so are you able to hear me?
Yes, sir.
Okay.
Yes.
Okay. So I'm going to hear the things. Able to see the screen?
We can see, sir.
Yes,
So
sir.
yeah. So what you have to do here is both the things I have given. Okay, and see that this is group statistics. For first group, it is a mean and standard deviation. For the second group, these are number of observations. Okay, and see that this is the mean for the second group and standard deviation. Okay, now what is 9 minus 9 plus 7? 9 plus 7 is 16 minus 2 minus 2. Okay, degrees of freedom is 14 here. Okay, and you need to remember here these two things. Okay, so when you want to do the the t-test for equality of means, and you need to remember the relevance test for equality of variances. Okay, so it will give you the results for this one. Okay, first, maybe if it is significant, it is, if it is not significant only, we need to consider. And what are the assumptions they have given here? Equal variances assumed and equal variances are not assumed. Okay, so we assume data has equal variance. Okay, so we need to consider the first one. Okay, if your data, okay, is not equal variance. Okay, we are assuming that. Okay, we are assuming that the variances are equal. Okay, so now we need to cover these variances. Okay, if it is not significant, okay, in this year, the same thing, like what actually we are comparing here means in for t-test, but f-test is used for comparing two variances. Keep remember that I'm not touching here, but when we do this, it automatically comes here. Okay, for comparing two variances, okay, two group variances, we are going to perform variance test. Okay, when it comes for ANOVA, there we are checking between groups and within groups. Okay, there we are going to use this the variance f test. Okay, that we are going to see that in detail. Okay, and you see here what is the see, we need to consider the first one here. Okay, what is the calculated value? 0.571. Okay, 0.571. Okay, are you able to get my
Yes, sir.
voice? No. So why means internet is coming, it's not stable. Okay, so that's why I'm worrying. Okay, and see that t calculated value is here. Okay, we are actually assuming variances are equal here. Okay, so t test is calculated value is 0.571 with the degrees of freedom. What is here? This is an important thing. Okay, p value is greater than 0.05. Okay, what we can do now? What is the conclusion we can draw from this? Okay, what is the conclusion we draw from this?
We reject our null hypothesis.
No, no way we are rejecting null hypothesis. What is the value here? This is more than 0.05. Okay, if it is less than 0.05, we are able to, okay, we have a provision to reject the null hypothesis. Okay, there is no evidence to reject the null hypothesis here. So y means these are more or less means are more or less same. Okay, see, observations are different here. Okay, more or less means 34, 37. Okay, nearby only. Okay, you can see that how maybe without doing anything you can tell the t-test. Okay, so by seeing the means you can tell. Okay, whether it is the difference is more, then it definitely give you. Can we try for a significant for this? Okay, it came now, not significant. Can we try for significant for this data only? Anyone? I'll just go to this material and show you. Okay, and see, these are the steps we have used there. Okay, and whatever we have done there, that came here. Okay, and see that. Okay, what is degrees of freedom? T calculated value is 0.571, and P significant value is 0.577. Okay, so this is greater than 0.05. Okay, so there is no evidence to reject the null hypothesis. Okay, this is, we are telling it in a statistical way. And what we conclude, we have to conclude according to the problem specific. Okay, this is the statistically we have concluded, we have interpreted, but when we write this one, okay, when we write this only we are applying to your domain one, okay, specific problem. Okay, hence we conclude that there is no significant difference between the mean marks of a student in the first group and the mean marks of the students in the second. Okay, this is the thing you need to remember for t-test for equality of means. Okay, still you have any doubt in this? Please ask me.
Sir, just one thing, like we did the grouping thing for the t-test in this. What could we have taken it as variable 1 and variable 2 and then conduct the t-test? Like, would that have been possible?
Means you are telling about grouping.
Yeah.
So grouping, we are dividing. Okay, this group from this particular this set of observations comes under this group. Okay, what is your exact question? I'm unable to get you.
No, so instead of grouping it, we could have just put the first group in variable 1 and second group as variable 2.
Oh, that is not how you can define, segregate this group from this one. How you can do that? Okay, when the spreadsheet is there, I'll show you that. I'll show you that also. Okay, most of them do mistakes there only. Okay, be careful in doing that. I'm telling you why it comes. Okay, this is actually multiple regression. I'm closing this. Okay, I'll touch this multiple regression also in the last session. Okay, many of them will do the mistake. If I do here, what happens? Okay, so I'll keep this one here. Okay, somewhere. Okay, if I'm writing here, how you can group now? How you can group now? Okay, how you can specify here? Okay, these samples from this group, how you can specify? Okay, for variable 1, this is the marks of entire students, and we have divided that group into 2 groups. Okay, so here comes the picture. Okay, this is the main important, those who did these things. Okay.
Okay, sir. Okay.
Yeah, keep remember that. Okay, most of them do mistake here only for doing t-test and Anova also. Okay, for entering the data into SPSS, most of them fail. I'm telling you why they fail. Okay, nowadays we have so much of internet sources so that we are able to get. Okay, before that there is no much things. Okay, so and when we go for doing it, and most of them don't know SPSS much. Okay, so keep remember that this is the main important thing here. Okay, I'm touching one more thing, the t-test for paid samples. Okay, and we will close the session for today. Do you have any doubts so far?
Clear.
Shall we go to the next one?
Yes, sir.
Good. I'll open another type of test. It is also from t-test only. One moment, I am actually. So what can I do is screen is not visible to you. You open the screen. Okay, now we are moving to the another test. Okay, another t-test only. Okay, it is before that what actually we did is what we consider the variables are independent. Okay, that equality of means. Okay, we also call that as t-test for independent samples. Okay, t-test for independent samples. Okay, now here we are coming for dependency. Okay, one variable is depend on the another variable. Okay, that's only the dependency case, how we treat this one. Okay, so this useful for, okay, so for example they have given here example of weight before, weight after. Okay, so these things means when you are dealing with any of the things with a single observation, where single sample, we have two observations here. Okay, so before and after. Okay, so if here they have considered physical training program by the army. Okay, we can take it maybe in the animals or maybe set of people. Okay, so before and after food. Okay, they have given here for physical training. Okay, so how they have gained their weight before and after that. Okay, so we can do it for say animals or any people, maybe those who are working in a nutrition background, or maybe when we are going to take a repeated sample. Okay, 2 times. Okay, someone is making noise. I don't know the name. Can you able to see someone able to see the name and we can specify them? Okay, now what happens when we come across the situations where the sample depending on have two observations. Okay, one is dependent on another. Okay, there comes the picture of parity test. Okay, here also we are comparing only two. Okay, so when we go for more than two, okay, there is a test called repeated measures ANOVA. Okay, repeated measures ANOVA. Okay, that we are actually going to use for more than two groups. Okay, I'll tell you the example how the repeated ANOVA will come. Okay, so when you want to check quality of water in a river, okay, you are checking yearly once. Okay, every time you are going to a same place and checking the quality, means what are the minerals. Okay, minerals existed in the water and how the ranges of that one. Okay, so you are repeatedly conducting same thing, means repeatedly doing same experiment. Okay, so with the different time periods. Okay, there it comes the picture of repeated measures ANOVA. Keep remember that. Okay, when you are dealing with more than two groups like this, you are going to use that repeated measures ANOVA with the same testing conditions only and same place where you are actually going to do that. Okay, so now what actually we have taken this problem. Okay, I'll show you here the formula for that. Okay, this is a paired comparisons. Okay, so this is deviation and we are comparing with the population mean. Okay, d bar minus mu d. Okay, if actually here also this is coming for n minus 1 only. Okay, why means there are only observations, the samples, but we are dealing with the different observations. Okay, now we go for this one. What we have taken, the young recruits were put through a strenuous physical training program by the army. Their weights were recorded before and after with the following results. Okay, so recruiter means this many recruited, 10 candidates were recruited and their weights. Okay, weights before and weights after. Okay, so these using 5% of level of significance. Okay, that we actually do here. Okay, should we conclude the program, conclude that the program affects the average weights of the young recruiters. That's only our main motto. How we actually we are going to conclude here. Okay, so what is the null hypothesis here? Okay, null hypothesis here is that there is no significant difference in weights of young recruits. Okay, young recruits before and after the training. Okay, before after the training. Okay, so here they need to add one more thing. What? Okay, here something is missing. What is that? Anyone?
average.
The third case
Yes.
where U2 says.
Our case.
Yes, average sir hai. Average.
Yes. Okay, very good, very good. You are very what we can say closely monitoring the things. Thank you so much. And see that, and this is the alternative hypothesis. I'm going to see here. Okay, data. I don't know exactly done this one. I did not copy the items in the bar, but it is there with me already. It is there with me already. Don't worry. Okay, I already copied this information.
What was that was missing in the hypothesis?
Someone is
iTunes कहाँ है? मेरे फोन में 10 iTunes अरे घंटों लगेंगे यार कर दीजिए वो हमेशा नहीं रहेगा फोन में आ जाएगा ना नहीं वो हमेशा फोन में तो रहेगा तो मुझे कभी अभी ले लो फिर उसके बाद में इंस्टॉल करके मैं कर देंगे बैकअप पे चला थोड़ी जाएगा
Who is Alka Singh? Please
यार
mute
ये तो
yourself.
मुझे अपने फोन से भी छोटा फोन हो रहा है मैं कहा था 11 मंगा लो तो मुझे लगा था उससे भी छोटा होगा ये तो कभी देती नहीं 11 21,000 में था 11 69 का 68 का था 69 का था 256 नहीं था 256 69 था
What we can do? Alka Singh, mute yourself, please.
गूगल से ये तो मुझे अपने से भी छोटा लगता है नहीं उतना ही है
Not doing that.
नहीं छोटा ना क्या कर रहा है रिटर्न कर दो तो पैसे भी दे दो
It's not here. Okay, what we can do now? We go for starting here, and we'll present the SPSS screen. Okay, so now
69 का है
what is that? Okay, now these are the recruiters, and both the variables are different. Means one is depend on another. Okay, are you getting my point? How the data is
पहले पुराना आईफोन दो
inserted? Still disturbing. Okay, Alka Singh, I think.
अब उधर बैठा कर सकते हैं कंप्लीट टेस्टिंग करवा लेंगे जाने टाइम मुझे उधर नहीं मैं भी तो देखूं क्या कर रहे हैं आप पापा जी के रूम में
So host also not there now. Will be भैया.
पर इससे छोटा है मत निकालो चार्ट मत निकालो दिखा रही हूं ना देखो
Okay, are you able to see the screen? Last.
Yes, sir.
Yes, sir.
Jill, please to mute them.
चलो चार्जिंग में लगा दें इसको मैं वहीं ले चलूं नहीं ये नया वाला हाँ तो वहीं ले चलो ना बैकअप लोगे ना इसमें
Okay, now some removed host has removed here. Okay, no problem. Okay, now what is the how we did here now? Okay, so here we are not grouping, they are different, but it is based on only one. Okay, so variable view. What is variable view? What we are doing here? The variable one, what is that? Okay, variable one is recruiter name, recruiters, number of recruiters. Okay, what it comes here? Okay, so these are scales. Okay, are you able to see this screen? Are you able to see the screen?
Yes, sir.
Okay. So now what I'm doing here, going for compare means and paired samples. Okay, so we don't require this one. We required only pair. Okay, in variable 1 we need to insert this one, in variable 2 we need to ask this one. Okay, are you able to get this one, how it came?
Please just repeat.
Wait before, okay, it is coming here as a variable 1, and wait after, it is coming in variable 2. Okay, this is a one pair, we are comparing both the pairs. Okay, now this is the same thing, confidence interval that we are doing here, and this is the only difference for the t-test for equality of means and t-test for the paired t-test. Okay, where the dependency case exists, we are pairing, okay, paired variables, okay, paired variables that only we are going to compare. Okay, now I'm going to the output window. I'll present my screen here. Okay, now see here. So it has given you, okay, for both the cases, and what actually we done here, okay, it has given correlation also. Okay, what we observed here, correlation. What we observed here, correlation. What is 0.978? 0.978. What it means?
Very high positive correlation.
Yes, yes. Very high positive correlation between the weights before and after. Okay, and you see here the pair one, what it did. Okay, this mean standard, it has given, we required this only. Okay, the difference, everything is they have given. Okay, now what we actually take this one as minus 2.147, and here negative things also possible. Okay, negative things also possible in t-test. Okay, negative values also possible to come. Okay, degrees of freedom, 10 minus 1 is 9, and see here what is the significant levels here. Okay, 0.06. Okay, 0.06. Okay, so whether we reject or accept this hypothesis. Anyone?
We are going to accept this hypothesis.
Yes, yes, very good. Okay, so these are the results that came there, and this is the calculated value we need to take, and we need to write like this. Okay, keep remember t calculated value at 9 degrees of freedom, that you need to write. Okay, 9 degrees of freedom. Okay, significant level is 0.06, so that there is no evidence to reject the null hypothesis. Okay, what we conclude now? What we conclude now? We conclude that there is no significant difference between weights of young recruits before and after the physical training program. Okay, that we are actually doing, means see what we are actually doing here. Okay, the mean you are telling, no, someone is telling mean. Okay, when I asked you, you have told me mean, but here we are taking the difference. Okay, that's why they did not means for each individual we are taking the difference. Okay, that's only the difference of a parity test and the t-test for equality of means. We are not comparing there as means, but we in one go, what I'm going to tell, that will consider the means. Okay, that will consider the means to compare, but the formula has taken di minus d mu naught. That is difference of both the ones. Okay, there also it will consider means. Okay, it directly we are not saying the mean weights here. Okay. Okay, I can. I think I'll stop here for today. Okay, we will be continuing with the Anova and regression. I'll do that. And one more thing is chi-square test for testing the attributes. Okay, that 3 things and some of the non-parametric test. I'll see that. Okay, thank you for your patience listening. Okay, and thank you so much. If you have any doubt, you can always welcome to ask me.
So just can you tell again the menu for the paid test, like just quickly?
Okay. I'll be doing it again. Okay, so what is there here? Weights before and weights after we have given, and the serial number that is actually we have given with a nominal, and this will not have any place here. Okay, pairing we are doing. Okay, so there is no problem in if not given this value also. Okay, analyze we are going for compare means and paired sample t-test, and see what I'm doing here. It is a very simple one. When you try to enlarge it, it is not coming. Okay, otherwise it will be okay, it is not coming. Okay, so now weights before I am keeping in the variable 1. Okay, weights after I am moving that one into the variable 2. Okay, there is no other than things. Okay, here we are accepting 95% confidence intervals, and missing cases also we are doing. So we are clicking OK. That's all.
Thank you, sir. Clear. Thank you, sir.
Okay. Okay. Thank you so much for the patience listening. We'll meet next week. Okay. Those who are having doubts, you practice. Okay, practice. And I will be sharing you some of the few questions to you. So try to practice with that. Okay. Thank you so much.